Sheldon Fernandez and Alex Wong, co-founders of Darwin AI. Welcome to the Data Exchange Podcast.
Thank you for having us, Ben. And good
Thank
to
you so
talk to you
much.
today.
And so I've known you folks since you were early supporters of an old conference I chaired, the O'Reilly AI conference, the old O'Reilly AI conference. So a couple of questions. First, many of our listeners may not be familiar with Darwin. So what is the origin story of Darwin? And how does the origin story compare to what Darwin is now?
That's a great question. It might be interesting to compare our different origin stories of Darwin. But since Alex actually, it was his conception before I got involved shortly thereafter, it might be useful to start with his story of how Darwin all kind of came together, and then I can add some CEO color, as it were.
So I'll start about that part, and then I'll let Sheldon take over. So it kind of all started because, as you might know, I'm a professor at University of Waterloo, where we have a very nice, successful lab there, where we kind of focus on helping and working with different industrial partners on different key challenges that they're facing when dealing with artificial intelligence, especially getting an operational scenario. And because of the insights we were getting, we were finding a lot of different key areas that they're having particular struggles with in widespread deployment and adoption of AI. With two of the ones which just mentioned is explainability, as well transparency, as well as on the notion of really understanding the level of trust they can have in the solutions they're building. And because of the great work we've been doing in those particular areas, that kind of had a springboard and said, hey, maybe we'll have a much bigger impact when we create a company to make the innovative research we've been doing in the lab into something of a tangible reality. And that's where Sheldon came in. I was fortunate enough to be introduced to Sheldon during that time. And another thing, apparently I've met him years back on a different endeavor. And so our ability to kind of rekindle at the University of Waterloo and have Sheldon take the charge in making this operational reality has been, I guess, pretty much kind of the origin story. So the superhero origin story behind Darwin AI.
Yeah, and Ben, I'll add to that a little bit. Alex, of course, is not just Alex. He's, Professor Alexander Wong, Canada's research chair in artificial intelligence. And him and the team have been working on deep learning for about a decade. So before me or you would have even known what it was. And even as academics, though, they recognize this idea of transparency as being a fundamental problem when companies would try to operationalize AI. So when I got involved, I was just supposed to be an advisor. I had just exited my first company, which I'd built over the past 15 years. We were acquired by Avanade. They're a much larger company owned by Microsoft and Accenture. And I was just going to advise Alex, but I encountered this IP around explainability and trust, and I it was too compelling not to get involved with. And so we entered the Creative Destruction Lab program in Canada, which is kind of like Canada's Y Combinator. And that's where we really started thinking about the commercialization of the technology and so forth. And I think there's been a couple of big realizations that we've had since we started Darwin. When we first started, in addition to explainability, you might remember this optimization story that we had, which was not just explaining, but really optimizing neural networks. In our experience, that was a nice to have for a lot of customers. It wasn't an absolute must because they were so busy trying to build AI that worked that, optimization was a third or fourth concern. The other was that if our technology was only if the benefits were only accessible to technical folk, data scientists and deep learning developers, we would get decent commercial traction. But in order to get it to that next level, we needed to articulate the value to business use cases that resonated with, our business stakeholders. And so that's what we've been doing. You might have seen, we've been in the news around aerospace and healthcare. So we certainly create all this foundational technology that Alex and the team have brought to life. But on top of that, now we articulate its purpose in specific verticals where deep learning is really a difference maker. And I think that's one of the big shifts that we've undergone as a company in the past, year or so.
So before we dive into what you folks are doing around explainability and transparency, so Alex used the word operationalize. And so as you folks probably know, one of the hot topics right now is ML ops, right? So, but most people who do ML ops, they don't necessarily focus on transparency and explainability. So they do other things like serving and deployment, observability, monitoring, CI/CD for ML, and so on and so forth. So why did you folks decide to focus on explainability and transparency? There's many aspects of ops for AI and ML.
Yeah, go ahead, Alex.
Oh, sure. Yeah, I'll speak to that. Yeah, so a very good question, especially because there's many entry points in the ML ops pipeline. So why choose explainability, transparency, and trust? Part of the reason is, first of all, due to our expertise in that area, but more importantly, having looked at the entire ML ops pipeline, one of the things that a lot of people have missed is the notion that trust as well as transparency is actually critical and pivotal at many different steps in the ML ops pipeline. And so right now it's kind of treated as an afterthought, but by the time you get to the end of the ML ops pipeline, and then you start discovering problems with biases, gaps, and so on and so forth, and trust issues, guess what? You're going back to the beginning of your ML ops pipeline. You're essentially starting from scratch. So what we see particular value about trust as well as explainability is that it actually fits in many different locations in the MLOps pipeline, from design to training to deployment, all the way to monitoring. It allows us essentially to have entry points so that at each point in the pipeline, if there are issues, even at the data assurance location, if there's issues, we could fix it, correct it early, and allow for much smoother, downstream in the MLOps pipeline.
I think one of the big insights that Alex had, and I wrote this down about 18 months ago when he first said this sentence, and I used it in a piece that I wrote for Medium. He said, there is no data understanding without model understanding, and there's no model understanding without data understanding. And so this idea, because machine learning manifests on data, when a model does something, you're seeing that model's interpretation of a set of rules that it's learned from that data. But that set of rules is opaque to design, or sorry, it's not you don't understand it. And so what you're seeing in the ML ops space, at least what we've seen, is it's this complex workflow. Some organizations, of course, like Microsoft, like Amazon, are going after the whole workflow and trying to automate it in their respective clouds. Most other companies are, trying to solve one particular step in that workflow in a very detailed way. We kind of overlay that because when you start to understand models and you understand data, it pervades the entire workflow. Now, we don't want to be an engineering company that's going to create an alternative to TensorFlow or PyTorch. That's an engineering level of expertise, and it's not something a company our size would have resources for. But we're trying to crack a very specific problem that touches all the other areas. So there are areas of integration that our tool set will pervade into. But to us, it's the all-encompassing problem of deep learning in general. And we're starting to see that with some of the clients that we've been working with.
So for the people who don't necessarily spend a lot of time thinking about explainability and transparency, so here's kind of a basic entry-level question, and you two can answer it. One on the academic side and one on more of the business and commercial side, which is basically, when you talk about machine learning and AI, right? So is the model good? Well, yeah, I'll look at some metrics, machine learning metrics. I'll look at error and so on and so forth. Explainability and trust, it's a bit subjective, right? So on the research side, how do you tackle how do you compare two notions of explainable and transparent ML? And on the business side, how do you validate whether something is explainable or transparent enough?
Alex, you're up
I
first.
guess I'll start off on the academic side.
Yeah.
And so and I think the point that you brought up on the subjectiveness has, I think, been the main chronic problem in explainable AI. And so what we've done is we've done a very different direction. We focus on two different aspects. One is quantification of performance of explainable approaches. It's easy to give an explanation. Anyone can give you an explanation for anything. Whether that explanation actually clearly reflects the decision-making process, that's a whole different matter. So what we've been doing on our side is we've been doing research on how do you quantitatively evaluate whether or not a particular explanation provided by an explainability approach actually, in fact, links to quantifiable impact on the actual decision-making process itself. Example I always like to use is I ask you a question like, why did you think this way? And you give me an answer. And I were to ask you, okay, great. Okay, suppose this was not part of the equation, right? Tell me, would you have decided the same way? If your answer is yes, I would have decided the same way, then clearly your explanation doesn't really reflect your decision-making process. And that's how we've been able to quantify and show that certain explainability approaches are better. On the second notion is better. Focusing on qualitative explainability.
I was going to have Sheldon now explain your explanation.
Okay.
A second order explanation, as it were. So on the first thing to note is we authored a pretty important paper. I shouldn't say we. Alex and team authored a pretty important paper saying, how do you verify the results of your explainability algorithm? And they used a very clever counterfactual approach where they compared our technique to Shap and Lime, and we've made it available online. People can evaluate that for themselves. But to get to the business problem, Ben, which is another side to this, the first thing I'll say is even the business people I talk to, CTOs, VP of Engines, business, they do understand that AI has a black box problem. They may not know exactly what it is, but in some intrinsic way, there is the understanding that it is difficult to trust the predictions made by AI. And so the question we get asked is, okay, this explainability for a paper, that's one thing, but Sheldon, I need somebody who's not technical, an operator in the field, a clinician, for example. How do you surface explainability to them in a way that makes sense so that they can validate that the AI is making its decisions in a way that aligns with their human experience? And to give an example of that, in March of last year, when COVID became quite acute in Canada, Alex and team, using our platform, very quickly developed a neural network called COVIDNet that diagnoses corona based on chest x-rays and CT scans. And we surface the result now to radiologists. And radiologists will look at, okay, where is the AI looking in the human x-ray to determine if somebody has corona? And in the early days of designing the system, Alex often tells the story, it was looking for the divot when somebody was lying on the hospital bed. And so that's an example where the AI is reaching the right decisions, but for the wrong reasons. And so you need to be able to identify these edge cases, because if you don't, it'll fail in ways that you didn't anticipate. And so that level of robustness is what our enterprise clients are scared about. Think about those in defense, in heavily regulated industries like pharma, like healthcare, like financial services. That's why explainability is so key to them and why they find our technology quite compelling.
So let me ask you this. In that example, the COVID example, what if in the process of developing the model, Alex, you actually worked with radiologists, and so they had some kind of input, I suppose, or influence over the model. So then they had a level of comfort once the model was done, kind of like a human in the loop or an expert in the loop development process. Would that work as a way of building an explainable or transparent system, or are what you folks trying to do something like let's build a system, or someone else will build a system, will come in and do the audit and explain it after the fact?
Well, I'll add a little to that. So for me, it's less about after the fact, but the first point you brought up, which was human in the loop, or what we usually call as human-machine collaboration. By doing this early and having human in the loop, in the example that was given, a radiologist, you get insights early into whether or not the model or machine is actually making the decisions in a way that they can trust and is logical for them. So for example, in the example that Sheldon gave was great, right? Clearly a clinician would never look at the divot in a hospital bed to identify whether a patient has COVID. But by having this particular system, which we recently done, we're able to then show, by correcting for these data issues, model bias, and so on and forth, they're able to say, okay, great. The AI is looking at the ground glass opacities in the lungs, the bilateral abnormalities, the honeycombing effects. And when they see it, and they can actually find consistency and alignment with their own clinical interpretation, then we know we've done it right. The AI is exhibiting correct behavior, and the radiologist can know that, great, I could trust the system because it's pretty much making decisions that are clinically relevant. And I think that's one of the key points.
So what is the workflow then in your system? So you folks are part of the model building process, or do you come in after the fact?
Yeah, so people will use our platform during the model building process to get these insights that Alex mentions, and that usually is used in an iterative way. So one of the pieces we published was how we built COVIDNet in 7 days, and we show how our GenSynth platform was used in that process. Now, that said, some of our clients are new to deep learning and are new to the whole machine learning ethos in general. So in that situation, we'll work alongside them to bring them up to speed, and then they will then inherit whatever we develop along with the use of the platform. So it's the situation where because some companies are new to this, it's in a period of adolescence, you're giving them a very powerful tool set, but you got to give them the knowledge to use that tool set. So we'll do a little bit of co-development, but then thereafter they're using our platform on their own.
So Alex, do you envision this work as mostly, so it's pure ML? So by that I mean, imagine a scenario where you do have someone with deep domain knowledge who can provide some domain expertise. I guess, I don't know what to call it, rules, I guess. So is there a way to incorporate that sort of domain knowledge into an ML system in a principled way, so that you get the best of both worlds, right? So you get someone's, so imagine examples or cases where you just don't have enough examples to label, right? So maybe you're looking for failure in a piece of equipment, and that piece of equipment only fails once every 20 years. I don't know, I'm just making it up, right? So, but then human knowledge might have a way to help you build a system where it's both explainable, transparent, and principled.
Yes, I think, yes, the answer is exactly. And so one of the key things is that right now, by having the notion of transparency and explainability early, it allows us to identify what are these key gaps that human knowledge, human domain expertise can allow for, which we can then take and incorporate back into the ML algorithm itself as additional priors, constraints, or knowledge they could build upon. So for example, in a more recent work, what we done was we were building language models, and we're able to incorporate clinical domain knowledge from textbooks and so on directly into it, because we're able to find that these insights, things based on explainability, can actually help improve the understanding of the ML model under these kind of situations.
Ben, the other important thing I'll add is one of the fascinating things we've learned about explainability is sometimes, not always, but sometimes the AI system will educate the human expert on areas that they never even thought about. So there's this famous example that Alex has where he was doing work with, I believe it was cancer and CT scans. And if you do a side-by-side and look at what the radiologist was looking at and then looking at what the model was looking at, they're almost identical, but there are certain areas, I think it was the walls of the lungs, Alex, or something similar, where humans just weren't looking there. And instead of saying, well, that doesn't make any sense, it prompted them to say, wait a second, is there something here that's clinically relevant that historically we just haven't looked at it? So it's really incredible to see now AI, in fact, informing the human expert in certain situations.
So the two of you wrote parallel. So Alex wrote recent academic papers too, and then Sheldon wrote two really well-written posts on Medium, I guess, kind of to accompany those papers. But basically, so in a nutshell, so the folks listening to this episode may be familiar with existing techniques like Lime and Shapley and all these things. So, what's the key takeaway from these new tools that you folks have built?
So again, I'll take the high level stab, and then Alex can add the academic support. I mean, the gist of it, if you look at Lime and Shap, and I wrote about this extensively in the Medium post, they are crude approximations of what a neural network is actually doing to reach a decision. They are local, they are subjective, they're unstable. Like you'll sometimes run an inference and get a different explanation each time. And generally speaking, explainability is an intractable mathematical problem because there are so many permutations in the network when you try to reach a conclusion. The IP that Alex and team have spent, years developing is essentially a way of cracking that in a tractable way. And, coming up with explanations that we can verify through a counterfactual approach are just a lot more precise in terms of positing why the network did what it did. And it's that accuracy that results in practical benefits we've seen for companies that are doing deep learning. Alex, maybe you can add to the academic.
So before you jump in, Alex, Sheldon used the phrase there again, precise. So how do you measure precision in an explanation?
Okay, Alex, that's a great question, and I don't want to embarrass
Sure.
myself by doing
No, that's perfect. So how do you measure it? So what we do is we measure what would be the result of a counterfactual scenario where suppose that you give me an explanation and then I posit to you, okay, in the counterfactual.
Wait. Before you proceed, let's have a working example, right? So I'm a radiologist and I say, well, this diagnosis is so and so because of this particular part of the image.
Yeah, perfect. I'll actually put it in the context of COVIDnet because that's exactly what we did. So here is a image of a chest X-ray, and right there, that particular area with the ground glass opacities is what I give you an explanation as to what the model thinks it actually focuses on as a critical factor of it being COVID-19 infection. Okay, great. So to be able to quantify whether or not your explanation is valid, what I can posit to you is the alternative scenario where my model is relying on other factors within the lung to make its decision. If I were to rely on other areas of the lungs and I make the decision, and the decision is no quantitatively different than what I would have made based on what the explanation has provided to me, then we know in this particular case that the explanation given doesn't give the full story, and therefore from an explainability perspective, it is quantitatively lower and reduced. Whereas in the situation where I were to give a scenario where I look at every other possibility and not what the explanation gave me, and it gives me a vastly different answer. So in this case, it tells me it's a fungal infection, a bacterial infection. Then I know for a fact that whatever the explanation have provided for me is in fact quantitatively reflective of the decision at hand.
Okay, so then that explains how you kind of judge the quality of an explanation. So now, what is the core contribution beyond Lime and Shapley?
Okay, so the core contribution, mainly because there's a proprietary technology behind it, the key contribution is the explanations that's provided by Jensen from an explainability perspective can actually give you a quantifiable difference. And that's one of the key things of quantifiable versus qualitative. And the other key thing is that rather than taking a local perspective like line, so the example I always like to give is the parable of an elephant and three blind individuals,
Right.
where they each touch a different part of the elephant and they each give a different explanation as to what the elephant is. Here, we give a global context in terms of explanations, so that we've taken all this global information in your data into account when providing the information, so we get a much more stable and consistent explanation that also reflects the real impact of the actual decision-making process.
So now in Sheldon's post, he makes a point of saying, here are the here are the must-haves for an explanation, and one of them is it has to work beyond the academic setting. So Sheldon, I'll put you on the spot. Does this work beyond the academic setting?
Absolutely. And so that, I mean, that's the whole point of commercializing this tech, right? It's one thing for us to publish papers at NERPs and so forth. They're meaningless to our stakeholders at, some of the big aerospace companies and so forth. And the ask is, okay, we get you can give explanations to, again, our technical folk, and that's fine, Sheldon. But what about my operator in the field that needs to use this AI in conjunction with their own expertise to deliver some meaningful result? And it's that level of explanation, call it contextual explainability or rich explainability, that our clients are asking for. And
so at a high level, Sheldon, what sort of UX, what is the user experience here? So in other words,
it's
I'm
different.
not a, let's say, imagine I'm not a ML person at all. I'm just a business person, right? So.
Yeah. So let's take an example, Ben, like anomaly detection for parts.
Okay.
Again, if I gave a deep learning explanation for why you consider this part defective, I'd get a heat map. That's okay for a deep learning developer. For an operator who doesn't even know what artificial intelligence is, they want to see, okay, what features in this image make you think this is defective? Can you show me comparable data in your data set that is similarly classified as defective? Give me context on a feature level of why you are making this claim. And I'm going to use that richer contextual feature explanation to ultimately decide, in conjunction with my expertise, if this is really defective, things like that.
But that means that the UX has to be rich enough to do all of that, right? So
Correct.
Here's the image that I think is an anomaly. Here's why I think it is. Here's comparable images.
And there's different. So we've created like the core API that'll serve this up. Actually turning it into a UX, we do some of that work, but we also have partners. Sometimes the client will do that work. You're right, though. There is a UX component to this. With COVIDNet, for example, you might have seen we were in the news with Boston Children's Hospital and Red Hat over a UX that was created for radiologists. You're absolutely right. Like, people need to visualize this in a way that is intuitive for them.
So let's go back, Alex, to what you talked about earlier in MLOps. So now I have a much better explanation. It's less subjective. It's more stable, more principled. So to me, that means then I can use also this explanation to judge whether or not this model is somewhat robust, ready for deployment. You know what I mean? So can I use this information to judge whether I should deploy the model at all?
Yes. And the answer is yes. So we've been helping different, partners and clients to do exactly that, to actually judge whether or not this model is particularly ready for deployment. And even if we judge it to be ready deployment, we could also then identify where it could potentially fail and put in fail-safe mechanisms. And that leads very well to the notion of trust quantification that we've also explored as part of explainability. So with the types of explainability that you might be used to, that we've just talked about, it's more about how and why a model is making a decision. Here, we're talking about explainability in terms of when and where a model is trustworthy and reliable when making a decision, and under what situations it's not. And so therefore, having this additional understanding of when I could trust my model and when I cannot trust my model, which facilitates for not only deciding whether or not something is deployable, but even in deployment, we could look for checks and balances to make sure either during the, monitoring phase, runtime phase, and so on and so forth, we know under what situations that it's going to give results that are dependable and robust.
By the way, Alex, so here's a follow-up question. So machine learning, just like any software, there will be failure. And so at some point, you'll have to, so I guess what companies want to do is make sure that they minimize that mean time to recovery, right? So if my model fails, I want to make sure I fix it, and then so it's up and running right away. So I imagine this technology can also help me in debugging a model when it does fail, right?
That's exactly it. And in fact, we've helped a lot of people do this kind of debugging, not just on the model itself, but also on their data itself that was fed in. So for example, using this kind of technology, we're able to help them identify that, well, the reason your model is behaving in this abnormal, undependable manner is because of this earlier step in your data that's driving its decisions. And so we help them trace that down. We help them debug this data quality issue. The data quality issue was fixed, and then the model's performance increased significantly and became a lot more robust and stable during deployment.
And Ben, just to give you a practical example, we had a medical client recently that was padding their images, right? Just to keep them at a singular dimension across the entire data set. And to them, it was just a pre-processing step to standardize their data. And then, we were able to show using this tool set, actually, the way you've padded these images is problematic because now the AI is looking at it. And they didn't even realize that was an issue. And as a result of that, they changed that logic, and the model, precision increased substantially as a result of that feedback. So things like that, because it's so sensitive to data and there's so much data, that's where this tool set can be, really, really critical.
So there's two hot topics right now in ML. One is ML ops. The other one is responsible AI, of which transparency is obviously one aspect, but there's also fairness, privacy, reliability, safety, security, and so on and so forth.
Yeah.
So it seems like this technology can help you in many aspects of responsible AI.
Yes, I can speak a little to that, and I'll let Sheldon add color to it. So that's exactly. So for example, in the area of fairness, recently we've put out a study where we actually leveraged this notion of trust quantification to judge and quantify the fairness and gain insights in the fairness of a system. And when we did that, we were actually get some very surprising results. So for example, in that particular study, what we found was the model that was created was actually quite fair in terms of its trustworthiness for different genders, but we were able to surface that it was actually being less fair by having less trustworthy predictions for individuals with only high school education compared to PhD, undergrad, and so forth. We were also able to surface that it was actually producing less trustworthy results and predictions for individuals who are over the age of 50. And so by having these kind of insights, not only can we build a better model from a pure numerical perspective, from a performance perspective, we're able to also identify and surface these types of biases, ethical gaps, and so on and so forth, so that they can be fixed and to enable a much more fair environment, a much more responsible way of making decisions.
So Sheldon, what do you say to people that might say, well, this is all great, but I'm in a fast-moving industry and we're not particularly highly regulated, so maybe I can table all of these considerations for later?
I'd say be careful for what you wish for, because not only the idea of your model being unfair can be such a disaster to your brand alone that it is worth investing in now, right? So there was the classic case of It was maybe a year ago, where I think it was Apple Pay or something. I might not be quoting it correctly, but two identical credit scores. One was female, one was male. One was given the loan, one wasn't. Like, that alone created so much backlash about the bias in their model and so forth, that even if you aren't regulated, the public perception that you could be unfair or disproportionately favor certain ethnicities or genders or what have you is worth addressing in and of itself. And so, you can take a laissez-faire approach to responsible AI and ethics, but in my opinion, and I think the market is kind of bearing this out, consumers will punish you for it eventually. So it is worth taking seriously as a problem right now, not to mention the liability that might eventually follow and so forth.
So Alex, what's up next with your lab? So what are some things that are upcoming in the next 6 to 12 months?
Oh, okay, that's a very good question. So, for example, we've been making a lot of traction on the notion of bias surfacing. So, from a quantitative perspective, we always talk about there might be biases in there. How do we actually better surface this information in a quantitative way so that you also have ways to actually fix it? The other thing that we've been really focusing on has been the notion, okay, great, it's great to surface all these inefficacies, unfairness, bias, and so on and so forth. What can we actually do about it? So there's been ongoing research on mitigation techniques, both during the curation process, to the training process, to the inference process, that allows us to put these additional checks and balances so that your model will actually learn itself to behave in a more guided fashion to avoid a lot of these biases, unfairness, and so on and so forth. So those are some things that we've been very interested in addition to a lot of the ongoing work we're doing on explainability and transparency.
So Sheldon, Alex and his lab, they're doing a lot of great stuff, but they keep publishing it on archive, man. So I don't need Darwin. I can just go to archive and GitHub.
You can try, but as you'll see, a paper will give you some theoretical ideas, but for the implementation, you got to come to Darwin. So Alex, for example, has published scholarship on trust, which is very important. But if you want to see how that manifests practically, that's where the years that we've taken to commercialize these ideas in a robust platform are so important. I should add also.
So Sheldon, you speak with a lot of companies. So what's your level? What's your assessment in terms of level of adoption for ML and AI? Because there's a lot of hype, but I think it's fair to say that companies are still getting started, right?
Absolutely. Now we have companies that are, at the advanced scale of the spectrum, right? They've been using TensorFlow since 2018. They're fully conversant in it and so forth. But there are bigger ones that are just now realizing that if they don't adopt AI, they're looking in the barrels of irrelevancy and they're starting to take it seriously, but they're starting anew. There are ag tech companies or mining companies, Ben, that are archaic and haven't even upgraded from Windows NT. If you remember Windows NT, I encountered that recently, that are now asking about AI. So the adoption is coming, but it is slow in certain industries, and we're here to accelerate those who are, feel they're a bit behind the curve.
So Alex, a lot of our discussion, we used the umbrella of deep learning, but it's fair to say that the tools that you've built work for all ML, right? So XGBoost and all of these things, right?
Yes, that's exactly it. So the way we've actually created the underlying technology is with scalability in mind. So deep learning is one of the things that we've kind of focused on as a use case, mainly because it's one of the hardest to get, transparency from. But similarly with XGBoost, it's more explainable, but it's not exactly the most explainable system. So what we've been doing on trust quantification, on explainability, generalizes to things like XGBoost, to random forest, deep neural networks, and so on and so forth.
But any kind of black box, so you can imagine a scenario that I painted where you might have a hybrid of rules, ML, and the ML itself is a hybrid of XGBoost, deep learning, and so on.
Yep.
Right?
That's exactly. So we've been able to unveil for these different architectures, hybrids of these architectures, as well as different types of input data. So a lot of people kind of focus on, okay, vision, right? Which is a very important thing, but a lot of times people mix vision with, let's say, clinical metadata, with all sorts of other information, clinical reports. How do we actually be able to explain these hybrid systems with hybrid architectures as well as hybrid inputs? That's definitely, I think, something that really distinguishes us from what others are doing.
Sheldon, let's close by talking about one of my pet peeves, which is ML people don't think enough about UX. And in many ways, explainability and transparency is UX. But even the way you described how your system ideally would work, right? So where you would surface anomalies and have someone compare and kind of the system itself, the way the UX is designed, engenders trust. So I don't think the ML reward system is too focused on error, reducing error rate, right? So not enough about the UX.
I fully concur, Ben, and you only get that insight when you really spend time with clients and customers, right? When you really put your preconceived notions of what ML is away and just focus on a problem they are grappling with and think about how they need to understand that, and then think of AI as the tool to get you there. And so that takes a lot of discipline, because when we're data scientists and deep learning devs, we're building things. We're used to fancy statistics and console outputs and so forth, but that's not who ultimately we're trying to serve. We're trying to serve a radiologist who is on the front lines diagnosing COVID in Malaysia or India. We're working with aerospace engineers. And I fully agree with you. If we can get that UX part right to capture the richness of the insights, that's where you really see customer wins.
And actually, a well-designed UX, Alex, can actually even help you, the modeler, because if the UX is designed in a way that the users can tell you when your model is not performing, right? So,
Oh yeah, no, most definitely. And we've been doing a lot of things in that realm, where we're able to help them really intelligently identify the different types of scenarios that have commonalities in terms of same failure points or same successes, so we could really surface these gaps to the modelers of the world. And I think, okay, great, this is what's causing my problem. I have something actionable to do to resolve that problem.
And with that, thank you, Sheldon and Alex. So to our listeners, I will link to various articles. So first, 2 sets of academic papers by Alex and his team, and then Sheldon very nicely summarized them into well-written and useful Medium posts that would be good reference points for people who want to understand the world of explainability and transparency. And I also encourage our listeners to watch the video of this episode, if nothing else, so that you can see the difference between Sheldon's background, which is like an office, and Alex's background, which is like an office in Cambridge or Oxford. And so thank you, Sheldon and Alex.
Thank you for having us, Ben.
Thank you so much.
This is actually Waterloo behind me, the new E7 building. I was on a panel with the dean. They asked me to use it, and so I decided to keep it, which is ironic since he's the professor at Waterloo. So I can dream, at least, and pretend.